Hello everyone, my name is Chidowere Jombu, your usual presenter. In today's lecture, we are going to holistically look at an inductor and see its applications and its values in electronic components and devices. Inductor, by definition, is a passive electronic component of two terminal which stores magnetic energy in a magnetic field when current or electricity flows through it. And this current might be a DC, direct current, or AC current. But both of them are differentiated with a particular property which they normally play when either of the currents are connected to an inductor, which will stay come into. So we are saying that an inductor is a passive electronic component of two terminals, which stores magnetic energy when electricity or current flows through it. Now let's look at types of inductors. One, we have the air core inductor. Two, we have the ion core inductor. Three, we have the toroidal inductor. If we can list them, we have one, air core inductor. Two, we have the ion core inductor. Three, we have the toroidal inductor. Okay, each of this group now have what differentiates one from the other based on their various applications. Now let's look at air core inductor. The air core inductor are needed where the applications demand that you use a low value, a smaller value of inductance, like the Henry, like the micro Henry, and we have that 1 millihenry is equal to 10 raised power minus 3 Henry. Then 1 microhenry is equal to 10 raised power minus 6 Henry. So these are the smaller values of inductance which is needed to connect when we are working with air core inductor. The next thing we are going to look at now is the ion core inductor. The ion core inductor are required where we need higher inductance value, like the Henry, H. So you can have like 40 Henry, 50 Henry, then 100 Henry. They are not the same with when you are working in 1 millihenry and 1 microhenry. So Henry is a larger unit of an inductor, while millihenry and microhenry are the smaller unit of what? Inductor. Now, the ion core, as widely said, are applied where higher value of inductance are required. Then three, the toroidal inductor. These are applied basically for their protective value and properties, like they reduce EMI, meaning electromagnetic interference. They reduce and alleviate EMI in the electrical network. So this is where toroidal inductors are needed. Now, another thing we are going to consider is the properties of AC current and DC current when they are connected to or are meant to flow through the inductor. And what are those properties? And these are the properties that differentiate their two behaviors. Like some people will say it's only DC that flows into an inductor. Some will say it's only AC. But the simple truth is that both AC and DC, all of them flows into the inductor. but differing because of the inductive nature of the component inductor. Now, let's see when we have the AC now, we allow it to flow to an inductor. You find out that one, it has a phase shift. The voltage now will now lead the current by 90 degree, or current will lag the applied voltage by 90 degree. You can see the effect when alternating current now flows through an inductor. Then another thing again is by behavior, the inductive reactance affect the impedance of that very particular inductor. That means the inductor now, by its inductive reactance inside it now, will always oppose the flow of current. And inductive reactance is given by XL is equal to 2 pi FL, where L is the inductance now in Henry. Then F is the frequency in hertz, while SL now is the inductive reactance in ohms. Therefore, we can now say that XL is equal to 2 pi FL. So SL now means inductive air reactance measured in ohms. F is frequency measured in hertz, while L is the inductance measured in Henry. So that is how it is. You can see the two behaviors of alternating current when they flow through an inductor. Now, let's see how it behaves now when it is with a direct current. With DC now, DC now still has two properties when current flows through it, or when DC flow through an inductor. One, we have initial state, and two, steady state. So when DC is applied to an inductor, there are two stages. One stage is the initial stage, two is the steady state stage. Now, let's identify and differentiate the two now. At initial state, what it means is that as DC is connected to the inductor, it develops a voltage drop and receives the current flowing. But after a short while, when it will now enter the steady state stage, it means it has built a magnetic field. After it must have built that magnetic field, it enter the steady state. And at this steady state now, what happens is that current now start flowing, because the inductor now will transmute and transform itself as a short circuit having a low resistance, and current now will start flowing. So you can see how DC behavior, or the how inductor behaves when a DC is connected to it. But the only simple thing there is that both AC and DC both flows into the inductor. But it depends now on the inductive nature of that very particular component, which is the inductor. This is where I draw my curtain close. Thank you and God bless you. Follow me on my page at Chidowere Jumbo. We meet in our next edition. Thank you.